Okay. People are still joining. Before that, let us also discuss. Like, okay, we will have a casual conversation, and then I will start with microservices. Guys, can you tell me what are microservices? Have you heard about microservices? Have you worked in microservices? Or have you tried creating applications using microservices? If you have done that, please do message in the chat window. I hope you all can hear me. Yes?
Yeah, we are able to hear.
Yeah. So I would like to have this as an interactive session. So if you have any idea about microservices, or if you have tried creating microservice application, please share your messages. Okay, very good. Few of you have done with few features, then yes, new to microservices. Yeah. What is the prerequisite for understanding and working with microservices? Any idea? So fundamentally, if you want to create a microservice application, it is not that you can develop microservices only using Spring. You can do it using other technologies also, be it .NET, or if you're working with Node, you can create microservice application, any programming language. In our case, we are dealing with full stack, that too Java full stack. So what are the fundamental prerequisites? Yeah, okay, very good. REST API, Spring. So obviously, the fundamental programming language that you need to know is Java. In Java, is it mandatory that I should know from the basic or everything? Be very comfortable working with collection framework. That is very, very important. And you should know how to integrate your application with database. So most of you might be knowing or working with Java. The next level is Spring. In case of Spring, what is that you need to know? You should know how to develop applications using Spring Boot. So this is very important. You should know how to develop REST APIs using Spring Boot. Okay. Now, guys, many of you are from different backgrounds. Few of you are working, few of you are looking for job, few of you are students studying in college. I can see few familiar names who are interacting and coming back to the webinar again and again. Thanks for that. And many working professionals, in spite of this, many working professionals have taken time to come and attend this webinar. Thank you so much for this. What is the idea for this webinar? Let me just tell you. In December, we have done an application. I mean, we have done a 15-day Spring Boot Mastery Challenge where many people have learned Spring Boot together with me. They have started their journey with Spring Boot. Now, the idea here is I want to do a workshop on Spring microservices. So before that, I just want get your hands dirty. So the workshop will be completely hands-on. Now, before that, you should have an understanding about what are microservices, what is the purpose of it. Let me share my screen. It's time that we will get started. So in this 1 hour, first let us get an introduction to microservices. What are actually microservices? And what is the difference between a monolithic and microservice application? Then few advantages. I will not go in detail into advantages because I don't want to go completely into theoretical part. Then the very important thing. What are the components that you need to work with microservices? Guys, this is a very important part. When you go and search for blogs or anywhere, it's very difficult to curate everything and have it in one place. So if you know what are the components that are there in microservices, it will be really help you to identify what is the roadmap for learning microservices. So technically, this is very important that you need to know. And after this, what is very much important? Without a hands-on, how can we complete the webinar? So we will learn to create or to build one single microservice, how to register this microservice to Eureka registry, that is to a registry, and finally, how to test your microservice. Okay. So these are the topics that I am going to deal with. Before jumping into the topics, few of you are new here. Let me introduce about myself. I am Sripriya here. I have got nearly 20 plus years of experience training freshers and laterals in different corporates in Bangalore, Hyderabad, and Chennai. I'm a Java full stack trainer. Regarding this microservices, I have been doing it for many years, like 2016 or so. I have got a playlist of microservices in YouTube, but that is a very older one because during that time, the softwares that they used, they have all gone to maintenance. Okay. And I have done training for microservices for freshers, especially for experienced people in Harman in Bangalore and in State Street, that is in Martha, I mean in Bangalore actually. So both are of Harman, you all know, like the headphone, Samsung based. And the other one is like finance based, it is for a bank. Okay. Now we will, why I am telling this is when you are learning about the components, whatever you are doing will be open source. When you are doing it in your projects, based on the concepts, usually every company develops certain things. While explaining, I will tell you. Okay, first let us get an introduction to microservices. What are microservices? Microservices is a suite of small services. Okay, what are microservices? They are nothing but an architectural style where you are decomposing one single application into a suite of smaller services. What is the meaning of it? Suppose say I want to develop an e-commerce application. If you are working in a e-commerce application, what you need to do? You will be having multiple modules. So what can be the module for user? Sorry, instead of user, we can say customer, we will have a module. Then for product, e-commerce means it is selling products. You will have a module. Then what is the next one? For cart, shopping cart, you will have a module. For billing, you will have a module. For order, you will have a module. Other than that, wish list, history, so many other delivery, so many other things are there. Everything will be developed as individual modules, and many people are working in each and every module. So this is how you develop an e-commerce application. All these put together completely will be deployed as one single application. While deploying, what they will do is they will combine everything. They will create an EAR file. EAR means what? Enterprise RQ file. Means it's a zip file kind of. JAR means Java RQ file. Enterprise RQ file means it's a combination of JAR plus WAR. So that is an EAR file. This will be deployed in the server. Okay. So this is a monolithic application. Now, it is having few other disadvantages. We will discuss about that later. Now, let us understand what is a microservice application. In case of microservice application, it is a suite of smaller services. Now also I want to develop an e-commerce application. This time I will create everything as independent, self-contained services. So customer module will be independent, meaning to say that it will be developed by a separate team and it will run in its own process and it will be deployed. Okay, it is something like this is like a joint family kind of. Everybody is there. Finally, the head has to take a decision and everybody has to follow it. But in this case, there are multiple nuclear families. If there is something to happen, they will do their work on their own. They will plan their picnic. And finally, in the end, when they have to collaborate, maybe for a party, maybe for a wedding, they collaborate and work together. But for one single common cause. Okay. So now in this case, I will create this as a separate service. Then what about cart? Cart will be a separate service. It will be developed, deployed, and developed and deployed independently, meaning to say that it will run in its own process. Guys, here one single application, one single EAR file. But here this will run separately. This will run separately. Now again I have got order, then wish list, then billing. This means these are independent, individual, self-contained services. Okay, how actually this microservice architecture came into structure? This guy, Martin Fowler, he was the one who termed this microservice architectural style. And why actually, who developed it and how it became so famous? It is through Netflix. Netflix developed a set of OSS, I mean, open software solutions, with the help of which they made their streamlining smoother. Now, in this case, if you notice, these are all independent services. What about the database? In an e-commerce application, you will have one single database. Here, each service will have its own database. What about the team size? I told you already, nuclear family, right? So it means the team size should not be more than, in such a way that they can share a medium sized pizza. So that is the term that they have coined. So now in customer, maybe I will have 8 to 10 members. In cart, I can have 8 to 10 members. What about the database? Each microservice will have its own database. Okay, guys, you all have learned about Spring REST API, right? How do you create REST API? You, for book, if you are developing, that is one single REST API. It will have its own database. Now, if I want to add user, if I'm adding user also in the same REST API, it becomes a monolithic application. Meaning to say that I'm having all the modules. But in this case, customer will be separate, cart will be separate, order will be separate, wish list will be separate. Each one will have its own database. What is there in wish list? Nothing big. So what I can do, rather than creating an independent individual database, this wish list also can share the database with other microservice. That is one other important thing that you need to know. Remember, it is independent, self-contained. That is very simple. This is like a joint family. Everybody has to adhere to the rules and regulations. There will be dependency. They are tightly coupled. Customer class will have product. Cart class will have product. Billing class will have cart details. Order class will have billing class will have order details, product details. It means that there is high interdependency. But what about this one? It's not like that. Now, how do they communicate? I need to do communication, right? Same scenario. Here also I am having product. Customer wants to see the list of products. Customer wants to add the items to the cart. In that case, how do they communicate? In this scenario, the communication, my dear guys, it can be synchronous or asynchronous. What is the meaning of synchronous communication? I call you through my mobile, you pick up the phone and you answer. This is synchronous communication. What about asynchronous communication? I send you a mail. Whenever you are having time, you will open the email and then you reply me back. That is asynchronous communication. In case of microservices, you can either do synchronous communication or asynchronous communication. How do they communicate? In case of synchronous, they communicate using REST APIs or remote procedure calls. Okay, just like how you call one Spring Boot application from another one. For that, we use special classes. What about asynchronous communication? Asynchronous communication, for this, we will be using Kafka or RabbitMQ. Okay, what is the advantage? Actually, this is a real-time streaming platform, Kafka. Suppose the best example I will tell you. If I want to, I'm booking a cab in Uber. If I want to know the real tracking time, like how long it will take time to reach my house. So you are seeing the tracker, right? So every time, real time, even information has to be continuously given to the customer. Customer is me, so I'm consuming data. There is an intermediate, that is the Kafka server. What it is going to do is it is going to get information from Zomato or Uber and it is taking in the information. And my application is consuming everything to track the car when what time it will reach my house. Okay. Same thing for Zomato orders also. You are tracking your order. You want to know at what time it will reach. So for these real-time streaming scenarios, we will be using Kafka or RabbitMQ. Any questions till this? Yeah, it is good to go. Now that we have seen the pictorial representation, let me go back to the slide so that it is easier for you to understand. Remember, microservice is a suite of loosely coupled services. I don't have any dependency of any other service. If I want to get the data, I can get the data in the form of JSON. Marshalling and unmarshalling happens in the backend. We don't have to bother about it. If I'm creating a REST API using Java, explicitly I need to do the marshalling part and unmarshalling part. But now we are using Spring Boot. Everything happens under hood. Okay. Now, let me just open the slide. So what are microservices? It's an architectural style where you are decomposing your application into loosely coupled services. Each service implements a business capability. Is it mandatory that it is going to be like that? No. Just like how you are having design patterns in Java, microservices also have design patterns. Based on that, you can orchestrate your microservice application. As in, I'm doing an e-commerce application. So what I'm doing, I'm dividing it into a suite of services based on modules, functionalities. Now think about Amazon. In Amazon, we are having, it's an e-commerce site where it is selling products. So what I'm doing, I'm developing it as a suite of multiple services. But this Amazon not only has product selling, it deals with music, it deals with movies, it deals with the Instamart kind of thing, like where you can buy groceries. So in those scenarios, I will not divide it into business functionalities. I will have it as subdomains. Subdomains means it's a part of it. Be it Swiggy. Swiggy has got delivery and also Instamart, right? So it means that they are all part of, they all become subdomains. So those way also you can create it. There are some few other design patterns. Based on the database structure also, I can divide my microservices. Now, it is a suite of small services, each running it in its own process. Means each application will run in its own separate Tomcat server, communicating with lightweight mechanisms. That is either using REST or RPC or message-based APIs, which can be Kafka or RabbitMQ. Now, I told you what the advantages of using microservices. It is loosely coupled. Now, see, this is how you decompose one single service into a suite of smaller services. Product service. See, guys, actually, if you think in real terms, it is very real time applications. It's very easy for you to relate it. Now, this is an online application. So, think of an application like Zomato, like a delivery application. So, what and all you will have? You will have a restaurant service where it deals with restaurants, delivery service. Again, the same good old things, billing service, order service, card service, right? If at all, if you are working with booking an appointment with doctor, then you can have hospital service, doctor service, like appointment service. So there it changes. So based on the business functionality, you are going to divide your application into a suite of smaller services. Fine. Now, what we are going to see is what are the key concepts. Let me quickly go through it. I already told you it is independent and self-contained. Means every service can run independently. It doesn't depend on it. Now, it is taking care of single responsibility. Like just like your solid design principles, responsibility. Meaning to say that if you are dealing with product service, it should deal only about products and product related stuff. Not about user, not about cart, not about order. If I have created a microservice for product, I should return a list of products by category, list of products by price, list of products by brand, and so on. So this is very important that you need to understand. And remember, it should also follow the design principles of Java. Design principles, not pattern principles, which is solid single responsibility principle. So each microservice focuses on one feature and functionality. Independent deployment. I told you already, you can deploy it independently and you can run it separately. One service will run in port number 81, one will run in 82, the other one run in 83, and they can communicate between each other. How do they communicate? There are different ways. We will discuss about that. Decentralized data management. Each one can have its own database. Inter-service communication, either using REST or gRPC or using message brokers. Okay. Now, what is the difference between monolithic and microservice application? In case of a monolithic application, many of you are working professionals. You know that The code base is huge, right? So this is monolithic and this is microservice. Okay, let it be. But what are the disadvantages? First, we will see. Here, the code base is huge. It means that a new person who is entering into this particular project needs time and KT, right? So you need to provide training, knowledge-based training, so that he can start working in this application. The second one, scaling is really very difficult in case of a monolithic application. And you cannot add scaling and extensibility also. Whenever you want to add new functionalities to an existing application. So I'm having his wish list. I have got orders billing. Now I want to know the history. That is not a part of this application. If I have to add it to this application, after you have added it, you need to redeploy your application. For each and every change, you need to do redeploying. So that is also biggest issue. The third point, scaling we have told. Yeah. Next is like suppose if there is an error, some functionality issues has occurred or the database goes down. See, even if the database goes down, they would have deployed the application in multiple servers, so you can take care of it. But still, if there is an error, then in these scenarios, after debugging your application, you need to redeploy it. Every time whenever there are changes, you need to redeploy your application. Maintenance is also very difficult. These are the drawbacks of any monolithic application. Okay. And monolithic, what is the difference? In case of monolithic application, it is tightly coupled. Why? I already told you. It's like a joint family. One class will have an instance of another class so that I can call the other methods directly. If the other class is developed by some other person and if he has removed some properties or if he is adding some properties, it may, there are scenarios where your code may break. So maintenance is also a biggest issue. It is tightly coupled. In case of microservices, it is loosely coupled. My dear guys, you remember when you say microservices, we are not talking about the front end at all. Front end at all. I will show you the pictorial representation after this part so that you will get an idea how a microservice application looks like. In a monolithic application, suppose I am developing a web application using Spring or using JSP servlets. What and all we will have? We will have the front end, which is the presentation, the middleware, that is the business logic, and the database, all put together and deployed as one single application. But in case of microservices, remember, you don't have a presentation at all. It's only your backend business logic developed as individual services. That is one single e-commerce application as individual pieces. So this is your microservice. Each service will have its own database. What about the UI? This application you have developed. There should be a front end which is going to call this microservice application. Okay. So here it is deployed as a var or EAR. In case of a microservice, it can be deployed as a simple jar file. Meaning to say that, my dear guys, it is very lightweight. Why? Because you are just going to write one controller or two controller, not more than that. Okay. Each microservice will have one or two controllers, few tables only, few model classes only. So it will be lightweight and it can be deployed as a jar file. These are the two major differences between monolithic and microservice architecture. Okay, now see here. Each functionality is a separate service. Each service is deployed as a set of service instances. Individually, you will be deploying it. I will not go into that in detail now. What is the difference between monolithic and microservice architecture? This is monolithic, this is microservice architecture. Okay. When will you use microservices? When will you use monolithic? Use monolithic when your application is small and simple. You have a small team with limited resources. Use microservices when your application is large and needs scalability. You are adding more and more functionalities. You don't have to go and dump into existing application. You can create it as a separate microservice and it can be taken care. Okay. Now, advantages already I have told you. Let me just explain with the pictorial representation how a microservice application will look like. This is very important. After that, we will see the key components. Assume I am developing a microservice application for an e-commerce site. Okay. So already we have seen that. What are the different services that we will have? Product service. Let me make it a little bigger. Wait a minute. Okay. Now first let us understand what is this. This is a microservice ecosystem. My dear guys, I want to develop an application for an e-commerce site. So it means first I need to understand what are all the functionalities that it is having. Based on that, I will develop the microservices. So I need to use the design patterns to develop the microservices. So maybe here I have product service. Then I have cart service. Then I have customer service. Maybe order service, billing service, and so on. So these are few services. Now, when you talk about a microservice ecosystem, how the other services will get to know each other? If I told you about joint family and a nuclear family, now everybody knows that you all have a group for your clan, right? Your family clan. If you are having brothers and sisters working in separate cities, you make a WhatsApp group for your family, which is your for your clan. So obviously you can talk to each other because you are independent, you are working separately, you are eating separately, you are doing whatever you want independently, but you are in a group. Same is the scenario. But how will you get to know that your sister is going to the theater or your brother is going to a party or something like that? They have to do give the information in the group, right? Similarly, how will I get to know the details about card service? How can I call the methods? So for that, first is the microservices should register themselves in a service registry. Okay. Guys, what we are starting with this, I'm just talking about the service registry. In real-time scenarios, they have moved to the next level. They will be using Docker. After that, the high level one is Kubernetes. But also, many corporates, they are using service registry. What is a service registry? It's like a place where I will go and register, like a WhatsApp group. If I want to join the WhatsApp group, I need to give my number. Similarly, my product service, what I want to do is, I want others to use my data, so I need to register here. This is called as a service registry. All the other services can access this product service now. Same way, every other service should register themselves to the service registry. Now, the open source service registry that is given by given by Netflix is Eureka. So this is the service registry. Eureka server or Eureka service registry. But when I was doing training, as I told you, in these two corporates, what they told us, these are all for laterals, okay? So they do not, because it's when you're doing training in, especially for banks, you will not be allowed even to access any of the outside open source, softwares, right? So in those scenarios, they develop their own in-house service registry so that all the services can register to that. So that is the first thing. So here it is service registry. In our case, we will be working with the Eureka server. Or you can use Consul. Or you can use Zookeeper. These are all service registries. First component. Okay. So this is how your microservice application looks like. And they have registered to the service registry. Now, what about the front end? How to call this microservice application? So for this, the client can be any type. The client can be a React or Angular application, or it can be a simple, or it can be a simple Spring MVC application, or it can be any other application developed using any other technology. My dear guys, I forgot to tell you one important thing. Remember, I have developed product service using Spring Boot. Is it mandatory that I should develop all the services using the same technology? Not at all, not required at all. Each service can be developed and deployed in its own technology. Maybe this one I can do it using .NET. Maybe this one I could have developed it using Python. Maybe this one I could have developed it using any other language. How they are going to communicate? As REST APIs only. So it is very easier. So microservices can be developed in any technology. Okay. Now here I have got React or Angular, which will give a nice UI. Using Spring MVC also you can connect to the backend application. Using any other application. Suppose say every application, whatever you are working with, now it uses Razorpay, right? For payment gateway. It means Razorpay also have a suite of multiple microservices. The application that is connecting to Razorpay is making an API call. Technically, these are all making API calls to the backend. All these services, they are all these applications are making API calls to the backend. It can be a front-end Angular application. Think this as Zomato, where you are seeing a nice look and feel. And what about Spring MVC? It is also like a proper web application developed using Spring MVC, which will have time leaf or simple JSP as your UI. Now this one also can be developed and deployed using any application. Maybe I have done it using Python or .NET or something else. Think of this like where I want to book a movie. I want to do payment. When I click submit, it has to go to the backend and pull the data and come back. So now please understand, the client can be in any technology. The microservices also can be developed and deployed in any technology. What is the common language? How they are interacting? As REST APIs or using message-based APIs. Simple guys. I'm in Bangalore. So many people from different parts of the country are here in Bangalore. How do they interact? The common language is English. Okay, they are from different parts, having their own nativity, having their own mother tongue. But still, if I want to communicate, I will have to communicate with the common language, which is English. Okay. Now, this is all fine. Will I allow all the microservices to communicate to the backend directly? Think of a scenario. I'm entering into the tech park where you are working. Can I come to your company and approach you directly? It is not possible. Why? Because there is always a security or a gatekeeper who is there, who will check my credentials, my authentication. Then only he will allow me to go to the backend. Allow me to connect with you. Same way, in our case also, we are having something called as gateway API. Okay, gateway API. Through this gateway API only, we will be connecting to the backend services. Now assume these microservices are running in different port. This is running in 81, in 82, 83, something like that. And now this gateway API is also kind of a server where it is running in a separate port, 9000. Whenever the front-end applications wants to communicate to the back-end microservice ecosystem, remember please, this is whole application. If you are saying that you want to develop a project using microservices, you have to develop individual applications and connect them together. So the whole thing is there. Now, to these applications, I will not expose these microservices directly. I will expose only the gateway API. The gateway API is responsible to connect to the appropriate services. So here also directly they will not connect. Will any corporate allow the security or the receptionist and go and talk to any person directly? No. I have to again go to the team leader. Think of a school. Now I cannot directly go and pick up my child. I have to go and talk to the security. Security also cannot go and pick the child and come back. He has to go and talk to the class teacher, who is a single point of contact. Similarly, We can also have one microservice, which is a single point of contact, which will connect to the backend services. Okay, it's like a point of contact. I go and talk to the security. Security will go and talk to the to the concerned class teacher, saying that this I want to connect to the student. Please, her mother is waiting, something like that. So you can have a unified microservice which will talk to the backend microservices. This is actually a design pattern. So this is how your microservice looks like. Now, what are the components that we have seen? We have seen service registry. Together with that, we have gateway API. Okay. Then the third point is like I need to handle what is that? Multiple services are running. So there are scenarios of exceptions. There are scenarios of faulty microservices. I need to handle fault tolerance. Then the next part is like, then I need to know the flow of my application to check the latency. What is the meaning of latency? I'm sending a request and a response comes back to me as a client for me. I want to know how long it is taking to do that particular circle, going from the client as a request and coming back to the client as a response. How fast it is doing it. So that and all can be tracked using Zipkin. That is distributed tracing. Then I need to take care of load balancing. This gateway API takes care of server side load balancing. We need to take care of the client side load balancing also. So client side means, guys, remember, for this whole microservice ecosystem, these are all clients. Among the microservices, if I'm calling product service from card service, this fellow becomes a client for product service. If I'm calling billing service, card from billing, then this will become a client. So in these scenarios, I need to handle the load balancing. So that is called as client side load balancing, which is taken care by a library called as Ribbon. Here we will be using a different library, Resilience 4J. Other than this, you also should know about config server, where we will be storing all the configuration details. Okay, so these are few components that are there that we need to know for working with microservices. Now, I hope it is clear. This is the complete ecosystem. Now, time is very less. So what we will do now in this webinar is, now that you have got an idea, see, I will tell you one thing, guys. Microservice is way too easy to learn, provided you are comfortable with Spring Boot. So it's like kind of like you need to know how to use the component, where to add it, and you should have a solid application done using microservices. And if required, you can call your microservice application from a UI, either from React or from a Spring MVC application. Or else you will feel that what am I doing? Where exactly it is? Because you just create a Spring Boot REST API, you test it, then you will feel, oh, that's all like, but how it is interconnected? Only if we do it as an application, we will get to know. Okay. Now, what are we going to do? Let me just tell you. First is, we will create a simple microservice. Okay. Microservice, my dear guys, it is nothing but a simple REST API that you are going to create. Whether it is connected to the database, exception is handled, return type is a response entity, all that matters. But now we will be creating it as a simple REST API. The second one is, I need to register this microservice to a service registry. So we need to create Eureka server. So I have created a new workspace. First, let us create a Spring Starter project. File new Spring Starter project. Let me create an application. We will have an application for book. Cap hyphen. Type is Maven. Packaging is jar. Java version is 21. Okay, let us have it as com.example.demo. Let me change the name. Let me have it as greet app hyphen rest hyphen API. Okay, we are creating it as a very simple service. Click next. Now the Spring Boot version is 3.4.2. We need to add dependencies. The first dependency is web. You all know for developing it as a REST API. The next one is this is a client. This is a microservice. It should be visible for other microservices. So you need to add Eureka client. Can you see this? Eureka discovery client. Select it and click finish. The application is getting ready. So when I talked about the components, these, if you are comfortable working with all the components, then it means that you can handle microservices. Now let me open this. Select src main Java. I have got com.example. Now let me go and create the controller. com.example.controllers. Let me have a simple controller, greet controller. Click finish. Let me minimize all this. Minimize. I'll minimize this. Okay, control plus plus. Let me annotate it with at rest controller. Yes. And now let us add two REST endpoints. Okay, public string greet user, string username, return grade day plus user plus username. And let me add the path variable, sorry, let me add the URL pattern at get mapping slash greet. Okay. And yeah, I need to pass the username also, right? Username. And let us add at path variable annotation. By seeing this only, you will get to know this is a simple REST API. Okay. Guys, the URL pattern, of course, you can add at request mapping above. You can give the proper URL. That and all is there. As of now, let us do it simple. Because we don't have time also. Now for the next one, let me just get a list of books. List angle bracket string. Get books. Path variable, no path variable, nothing. Instead of get books, let me have it as show books. And let us return a list of books. Arrays.asList. Or you can use list.off. Both the methods are same. Arrays.asList. Java, comma spring. That's it. Import string. Sorry, import list. Show hyphen books. You can have any URL name. I have simply given it as show books. Maybe we will have it as greet slash show books. Okay, this is the URL because I want to start it with greet. That's it. Now, how do you run it? This application will run in port number 8080 without any problem, right? So first let us run it. Select your main class, right click, run a Spring Boot app. Now I'm getting an error. That's okay because we have added what is that? Eureka client. So what it is doing is it is trying to register itself to the service registry. But the service registry is not available. So it is giving me an exception saying that cannot execute request on any known server. So this means we need the Eureka server. Before that, yeah, first we will create the Eureka server. We will complete that part, come back and do few modifications in this. This is just a REST API. I need to convert it into a Eureka client. What are the steps that I need to do? Let me just tell you. So first is we need to create a Eureka server. This means I need to create a separate microservice which behaves like a Eureka server registry. Okay, so go to File, New Spring Starter Project. Let me give the name as greetab hyphen Eureka hyphen registry. Spelling is wrong. Registry. Type is Maven, packaging is jar, com.example. Rest of the things you can leave it as such. Click next. Now search for Eureka. This is a server. Select it, click finish. The first thing is open the main class and it what is that I have missed? Now I need to add one annotation to ensure that this is Eureka server. So add at enable Eureka server. Okay, so the first step is you need to add the dependency. Next step is add this annotation in the main class. Then the third step is we need to add the configuration details relevant to Eureka server. So let me open src main resources application.properties. Guys, usually we will use YAML. When you are using YAML, you can have your application name with a different name. But always remember, whatever you are giving in properties file, that only will be considered. So if you want to have the same name, leave it or else delete it. The first step is create the YAML file. Right click, new file. File name is application.yml. Yes. Now, few things we are going to do. That is few configuration details we will add now. First is I want to give a port number. By default, every application runs in port number 8080. For Eureka server, let us give the port number as 8761. It's not mandatory that it should be this, but they have given it as a default number. So I'm just using it. So first is server.port. Change it to 8761. Next one is I want to give my application a name. The name is the property is spring dot application dot name. Let us give the name as Eureka registry. The next property is I need to tell the URL where exactly the server is available. Okay, so for that we need to add the configuration file. Is it mandatory that you need to remember it? You cannot remember all the configuration. You can directly go to spring.io. You can take the configuration details and you can add it over here. Okay, so the next one is Eureka dot client dot service URL. Okay, means if the client wants to register itself to this Eureka service registry, they need to use this URL. Together with that, we need to add default zone. They don't prefer to use camel case, so it is default hyphen zone. What is the see, be very careful with the indentation. Oh, no space. Okay. So what is the port number in which it is running? 8761. So I need to give it as http://localhost:8761. Okay. Now instead of this, I can also give it with a different name. That is Eureka service instance name. I want the instance name. I forgot that. Let us get it from the configuration file. The purpose of that is instead of giving it as 8761, I can give it as $curly brace server.port, which is equivalent to 8761. So similar to that, we are also having service instance name, something. Let me give it as instance. Where I can get it, I will just check. Instead of checking it here, I will go to application.properties, type instance. Eureka.instance. Not instance. Eureka.instance.hostname. This is the property that I want. So what I will do is go to application.properties, Eureka : just to search for instance. Host name. So it has added it in the bottom. Now it is localhost. Now instead of this, I can also give it as dollar curly brace. It's not Eureka instance. Let me just. There is an instance host name. Let me just take it from there. If you don't want it, you can give it as localhost : 8761. This also is fine. Now I will go to the browser. Here, let me just type Eureka service registry. Now here, click on this Spring IO guides, scroll down. So we have added enable Eureka server. We have given an application name. Then yeah, this it is not having it. Okay, service instance name, it's not having it. I will get it. I will remove this one. Now, the other two properties we need to add. That is Eureka.client.fetch registry. What is the meaning of it? By default, whenever you are writing a microservice, the microservice should get the registry details. But this itself is a registry. So why should I fetch it? By default, the value is true. I need to change it to false. Okay. The next property is whenever you are creating a microservice, after fetching the registry, it has to register with Eureka service. This registry, correct? I will repeat. Whenever I am creating a microservice, I need to add the configuration details in that microservice also. So during that time, I need to tell, please fetch the registry. This is the URL that I will give. The second part that I will tell is, please register myself to this Eureka service registry. That is the information that I need to give. By default, it is added in the configuration details. But this is a registry itself. So why it should fetch itself? You should not self-register and self-fetch. Register with Eureka. Eureka.client.register with Eureka. This also has to be false. Okay. Now here we need this. Just give me a sec. Let me take it. So see these many applications that you need to do for developing one single microservice project. Resources, application.yaml. Oh, whatever I have given is correct only. Eureka instance hostname. I had a doubt actually. Yes. Then now here I can give it. Eureka instance dot host dot name. Dot host name, which is localhost. Now I can explicitly call it within expression language. The property is Eureka dollar instance dot host name. Okay. So these are the properties that are needed for our or the configuration details that are needed for our Eureka service registry. You cannot remember everything. This of course you can remember. If you want to know all these details, just directly jump into the browser and from there you can get the details. Okay. If you want to add logging, those are all extras. We don't need it now. Now save this. What next? We need to run this application. Select your main class, right click, run a Spring Boot app. See the name that we have given is shown over here, Eureka Registry. And now the application is up and running in port number 8761. So let us check it out. Go here, localhost 8761. Now you have got the Eureka dashboard. In this dashboard, it will show all the microservices that are registered to the service registry. In our case, we have got one particular microservice, so we need to register it. Let me quickly go to the application here. Let me open this. Now our Eureka registry is ready. What is the next step? Open the REST API. First thing is, this is a client. Sorry, this is a microservice. I want everybody to access this particular service. So for that, to make it visible for other services, you need to add enable discovery client. Okay. This means this microservice will be visible to other services. For that, first what we need to do, we need to register it. So select SRC main resources, right click, new file. Give the file name as application.yaml. Okay, again, as I told you, in application.properties, it will have its own name. Remove it. Then come back here in application.yaml. First, let us add the port number, server.port. Okay. Server.port. Let me give the port number as 8081. Next is application name, spring.application.name. Let me give the application name as greet-service. Now this application has to register itself to the Eureka service registry. So what I can do is I'll just copy it from the previous YAML file. So this is the part that I need, only till this. Copy it, come back and add it in the YAML file. Indentation is the biggest issue. Hey. Service URL. What about the default zone? So I'm supposed to give it as localhost colon 8080. Sorry, localhost colon 8761. But always you know that we are not supposed to hard code the values. This Eureka service registry is having a name. The name is Eureka registry. So I can give it as localhost colon // This is visible only for the other application. Go and copy the name Eureka registry. Means I am informing this microservice should register itself to this Eureka registry. It is up and running in port number 8081 and it is visible. Save all. Okay. So these are the configuration that you need to do for a basic microservice. Now let us run this. Select your main class, right click, run a Spring Boot app. Maximize the console. See the name of your application. It is Greet Service. First thing, whatever we gave. And see, there are two applications up and running. One is Eureka registry. The other one is your Greet app REST API. In which port number it is running, that also let us see. I'll pull it to the right. It is running in port number 8081. Okay. This is the URL in which it is running. Let me open Eureka registry. Eureka registry will show that it has registered this one. Registered instance, Greet service. Can you see that? Now let us check it out. I'll open the browser. Refresh this one. Now you need to see Greet service which is registered to Eureka service registry. How to test it? The application is up and running. It's not actually an application. It's a part of the application. It's a service. Click on this. Now it shows localhost colon 81 / info. These are all few inbuilt endpoints which are underneath. So we don't need this. Let us give the URL /greet/Priya. Yeah, we got it. The next one is 8081 /greet/show-books and showing the list of books. So I hope it is clear. What we have seen is how to create a microservice, register the microservice to Eureka Service Registry, and how to test it. Any questions? Yes? Is this all clear, whatever we have seen till now? Yeah. So guys, based on whatever we have seen, whatever we have done till now is just a point, not one part of microservices. We have just started with microservices. Now what I'm planning is for a hands-on workshop where we will be doing certain parts. Let me share the details. I hope you can see this. In this webinar, you are watching me do the code. Now what actually we are going to do is about a hands-on workshop. Okay. So in this hands-on work, yeah, you cannot dynamically add or delete a service. If you want to delete a service means you need to explicitly stop the server, then only the service will not register. What we have seen is using Eureka Service Registry. You can also run your application within a Docker environment, wherein like you don't need a registry at all. Registry at all, literally. In a startup, this SME, he explicitly told you, see, I don't want to use any open source. My guys are shifting from .NET to Spring Boot. So they need to develop microservices. They have to communicate it within themselves, within a Docker environment. Don't download MySQL. Don't download any softwares. So that training that I did for a startup, which is in Bangalore only in HSR, that was literally amazing because I had a great experience working with the laterals doing microservices where you don't use no registry. I will create all the microservices within the Docker environment. It's like as I told you, like a WhatsApp group where all the family members are there. They can just comment, they can joke, they can tease, they can cry, they can tell everything. It's like that. Okay. Now, guys, let me talk about the workshop. So, based on the votes and whatever we had, I'm just coming up with a hands-on microservice. Okay. So, this is about my hands-on workshop. Like what it is just for 2 days. You will be doing the application together with me. It's not like I continuously teach like a course or something. So first step is on day one, we will be building a microservice application. Meaning to say that it's not like a just whatever we have done. We will get an introduction to microservices. We have discussed this. We will deal it in detail. We'll see what are all the components, where exactly they are used, how to use it, what is the inbuilt libraries that are being used, what are the advantages of microservices. Then we will do a project setup. That is for a simple e-commerce application where we will be doing 2 to 3 microservices. We are not going to work with the database. Why not with the database? If I'm going to do the database, then the original scope of microservices is gone. If you are working with spring-data-jpa, then we need to learn about the database. Here we will work with a static set of values. We will create 3 microservices and they will be communicating between each other. So for that, first we will set up a service registry. We will register a microservice. The microservices will talk to each other. As in, I already told you here, I will have microservice A, microservice B, C. B is talking to C and okay, it can be in this manner also. Like as in I have yeah, product info catalog service, and then there is a rating service, rating or inventory service, whatever. Okay. Then I have a product info service. This fellow is going to return the data from the database. This is going to provide the ratings for each and every product. It can be ratings or it can be inventory. Like I want to know the stock, how much is there in that particular for each product. So this is one service. Product info service wants to show it to the user. So for that, this will connect to product catalog, okay, and to rating service. They'll communication between the microservices, and this product info service will have all the details. So these are the 3 microservices that we will be developing on day 1. Okay. Then now I need to, so this is okay, fine. You are just simply testing it. We need a UI, right? So for that, on day 2, we will create a Spring MVC application. And we will communicate from our MVC application. I have added one bonus. Though it is only for 6 hours, I will show you how to use Gateway API. Gateway API and all, guys, actually we do it. These are all really advanced concepts, but we will do it there directly. So from my MVC application, I will make a call through the Gateway API to product info. So that product info will give the final output. So in my, so what is the thing that you will see? It's like you are creating a full stack application. Okay. Full stack in the sense means what? You need to have a backend. You need to have a front end. What is the backend part? The backend part is nothing but your microservice application. The front end part will be your Spring MVC application. The final output will be something like there will be a search box and a button. In the bottom, you will get the list of products. Maybe if I'm searching by category or something, when I click submit, it has to show the list of products by a particular category. This way we will be doing the application. Okay. So these are for, this is for 2 days. Just have a look. Build the Spring web application. Guys, this is the course outline. How to communicate between the microservices using REST template, implementing Gateway API for routing, building an MVC client. This we will do it on day 2. Okay. Is it for you? If you have learned Spring Boot, if you know Java, if you want to experiment and do it together with me, of course it is for you. You can dive into microservices. We are not going to see all the components, but of course we'll have a solid application. We will have an understanding about microservices. If you want to do a hands-on together with me, you can come to this workshop. It's a live practical session. It's on February 16th and 17th. Okay, morning. February 16th and 17th, morning 3 hours, both the days. So totally 6 hours. It's not theory part, it's hands-on. So we need 3 hours per day. If I just split it to 2 hours, then the learning will not be complete. Now, for you guys, because you have joined together with me, it's $299. The original price is actually like I'm just giving 50% because I just want, because many of you are known to me and I have been together with you for this whole journey. So this is the one including GST. Let me share the. Whoever is joining can join today right away. For the others, this is the link. If you are ready for a hands-on to do it together with me, and if you guys are free on Saturday 16th, your Valentine's Day and everything will be over by that time. So if you guys are free on Saturdays and Sundays, morning 11 to, morning 10 to 1, 3 hours, 2 days, right? So, and if you want to really move up in your career ladder, starting with microservices, please try to join with me. I want to do a hands-on together with you guys. Any questions? Yeah, date and time. And Sunday, not Sunday. Sorry. I have given the date wrong. Wait, sorry. There is me. Yes. Sorry, excuse me. 1 minute, I will just tell you. This is February 15th and 16th, Saturday and Sunday. 15th and 16th, 10 o'clock to 1 o'clock. I thought of having it on Friday, Saturday, and Sunday. It will be tough because Friday is a Valentine's Day, and evening people will not be available. So I thought we will have it on Saturday and Sunday, 10 to 1. Okay, based on the count of participants, if you want to have it in the afternoon session, that also is okay. But now I have planned it at 10 to 1. Don't miss this opportunity. Um, Actually, the original price, what I usually do it is for $799. Now I have given it as $299. And I'm also building a course on microservices. I'll show you that. Now, where is my microservices course? I'll just take it. Any questions? So date is February 15th and 16th. It's a weekend only. So together with me, you will be building an application. And of course, you will see it using the UI also. That is the best part. Where is my notepad? So we have just started. So for this workshop, whoever is interested, I have shared the link in the chat window. Any questions, any doubts you guys want to ask? Is that all? Yeah. I hope you can see my screen. Yeah. I think I shared it. Oh, okay. Okay. So please, maybe we can have the timings different. Maybe in the on Saturday, we can have it in the afternoon, Sunday morning. That also is possible. So if yes, yes, of course. I'll share the notes. I'll share the GitHub link. I will share whatever is needed and also the resources, like from where you can learn it. Guys, actually, there are few websites which are available, few blogs which are available. It's okay to go through everything. I will tell you from where you need to take the resources. It's not that randomly you collect the resources and make it. Because when I started with microservices, I did not know an ABCD from where to get it. It was great, with great difficulty I took it because few people would have given one topic may be missing. So now I have curated everything. Going forward, after this workshop, I will also help you out what is the learning path that you need to do to become an advanced microservice practitioner. Okay. Yes, any more? I think I have shared again my page. Share. Sorry. Share is not done. That's why that's the reason. Okay, I think I have shown you this, right? Yeah, I think I have shown you this and also this. So these details I will just tell you what are the topics that you need to proceed further. What should be the next level that you need to move forward for learning with microservices. This is because many a times like what I am getting is like many people they want to know what are microservices, how to work with microservices. So I have just come up with this. This will be a starting point for you to enter into your microservices journey. But of course, it's not theory, it's a hands-on application. It's a one where you will be doing a complete project. Okay, guys, if you are having time, let me quickly show you one project that we have done. Okay. Maybe I should have shown you there earlier. Okay. Maybe like during the session, I can show you the project that we have done. As in, there is a front-end Spring MVC application. In the back-end, there are list of books. When the user is adding the books to the cart, it will be added. Finally, if I see the cart, it will show me the list of items that are available in the cart. These are the items. What is the total price? So the application that we are going to do also will be similar to that. Whoever is interested, whoever is willing to do the hands-on together with me, you can join. Okay, any questions? Okay. Thank you so much for everyone for taking time and coming here and attending the workshop.